This is Ollie. Ollie was a fisherman. During the monsoon seasons, Ollie cannot go out to the sea because of the safety reason. Because of that, Ollie took another alternative to make money by producing a dried fish. Once again, Ollie got a problems because during the monsoon season, there is not enough sunlight during the day, due to the weather change factors, as well as unpredictable weather. Ollie can only dry his fish with the presence of sunlight. Ollie also identified other problems with this traditional drying method. This traditional fish drying method takes quite a long time, up to 3 days for complete drying due to the volatile sunlight heat temperature factor. Next, this traditional drying method also lack of safety features in order to ensure the safety of workers and products.
As an engineer, we helps Ali to solve his problems by creating a new project which is called a smart drying machine. After this, we will explain in details about this project in this video.
Chapter 1 Introduction.
Our project contains 3 main objectives, which is number 1, to make sure the fish drying process continuously, second, to reduce time during the drying process, and third, to improve the safety features, technology, hygienic of the machine.
This project has 5 scopes, which is the limitation in this project. This project is basically focused on small to medium fish due to the cost. This project just maintaining certain temperature within 60 degrees Celsius to 90 degrees Celsius that has been set to dried fish. This project only uses C++ language for programming and CATIA for drawing. The system design will include performance, functionality, ergonomics, cost, safety, and aesthetic value in this smart drying machine. This project is limited to dry the fish average of 250 kg to 300 kg per day.
Chapter 2 Need Identification.
First, we did a comparing between 3 existing fish drying systems, and we set advantages and disadvantages for those 3 existing systems to come up with a perfect design or product for the smart drying machine. And then we did a questionnaire or survey, and we published it to the public, and we got 50 people answered the questionnaire. 29 for them was males and 21 females. We set the questionnaire into 3 sections. Section A was about the personal information. Section 2 was about the general overview. And for the section C, we focused more on the customer requirements.
Chapter 3 Design Specification.
After we did a questionnaire, we took the customer requirements that they applied in the questionnaire, which is the time saving, hygienity and easy to operate, productivity, safety, portability, and affordable. And we had to come up with perfect engineering characteristics that will meet the customer requirements in a best way, which is cost, weight, time, power, material, dimension, safety, and usages. And then we did a calculation in the house of quality, because the house of quality is a clearly method that will help you to do a relationship between the customer requirement and the engineering characteristics that you set it. And these are the customer requirements and the engineering characteristics, and this is our calculations. And then we did a product design specification, because that is the best way, and actually you have to do that before you start with the designing of the product you want to do it, because you need to set what you must supply in the product based on the customer expectation.
Chapter 4 Concept Generation.
Physical decomposition of smart drying machine was divided into 4 parts, which is mechanical subsystem, mechanical part, control subsystem, and power supply. For mechanical subsystem, we have blower and heater. For mechanical part, we divide it into 3 parts, which is wheel, tray, and transparent cover. For wheel, we have tire and locking system. Other than that, for control subsystem, we have Arduino, sensor, CCTV, and miscellaneous. For Arduino part, we have USB connector, microcontroller, and power port. For sensor, we have humidity sensor, temperature sensor, and smoke detector. For miscellaneous, we have wire and 3-pin plug. For the power supply, we have AC current, which is alternative current, and solar panel. Other than that, we also have power bank. Systematic design of smart drying machine. Systematic design, which is about the black box of smart drying machine. Systematic design also tell us about the input and output of the machine. So the input of the smart drying machine is solar energy, electrical energy, mechanical energy, human energy, sensors, heat, and raw product, which is raw fish. Then the output of smart drying machine is kinetic energy, potential energy, temperature, and humidity, visual for monitoring, and final product, which is dry fish.
I will be presenting about the schematic diagram in chapter 4. So human energy and electrical energy is put onto the switch, and this will trigger Wi-Fi signal to the microprocessor, which is Arduino. Arduino then will feed on signal from sensor like humidity sensor, temperature sensor, and smoke detector to operate, and thus send the output signal to the handphone for monitoring. The image displayed on phone is directly linked to the CCTV. So through the phone, one can control the blower by sending output signal, and thus it will trigger the heater to turn on. Both blower and heater will transmit mechanical and heat energy to the smart drying machine in order to produce kinetic and potential energy. Concept design. Concept 1. Concept 1 will consist of doorknob, wheel, polyvinyl chloride, battery storage, sensor, panel, solar, wire, plug, shelf, and camera. The advantages of this design is this machine is large and you can put many quantity of fish at once. The arrangement of the shelf is also bi-level, and which means this is also can put many quantity of fish at once. This design or this machine is light because it uses a PVC. This design has smoke sensor to detect burning or smoke if occurred. Disadvantages of the design is this design need a large space to put because of the size, and you also need to be cleaned once a week because of transparent cover will make the machine looks dirty. Concept 2. Concept 2 will consist of doorknob, stand, shelf, acrylic cover, plug, wire, camera, sensor, and handle. The advantages of this design is this machine or this design is small, and you also use material which long lasting and durable than concept 1. The material used is acrylic, and acrylic is more durable than the PVC. It also has heat sensor to detect heat and burning if occurred. The disadvantages of this design is this machine is heavy because all the compact components and structure are crammed into the machines, and the machine cannot dry a large quantity of fish at once, and it only uses electrical power. Next, concept 3. Concept 3 will consist of doorknob, door, wheel, polycarbonate cover, battery storage, plug, wire, solar panel, sensor, camera, and shelf. The advantages of the design is yes, it is large and can put many quantity of fish at once, and the arrangement of shelf is also bi-level and divided by left and right part. It have smoke sensor and also temperature sensor to detect burning and heat if occurred. The disadvantages of this design is you need a large space to place it, and you also need to be cleaned once a week. And last but not least, concept 4. Concept 4 will consist of camera, sensor, retainer, acrylic cover, stand, wheel, wire, plug, battery storage, doorknob, and solar panel. The advantages of the design, it is small, the smallest between all of the 4 concept design. It have smoke sensor, and it use both electrical and solar panel, and this will make the concept 4 can use continuously without any problems. And last but not least, the disadvantages of the design is it only can dry fish in a very small quantity.
Chapter 5, Conceptual Design.
In this conceptual design, we use 3 methods to find the best concept, which is analytic hierarchy process AHP, path chart, and weight distribution method. Analytic hierarchy process AHP. There are 7 criteria as follows: cost, weight, time, power, material, dimension, safety, and usage. For the example of adjustment, the comparison between cost in A and power in B is 3 since volume in A is slightly more important to weight in B. The cost and power are crucial in judging the quality of the product. Rating factor between cost in A and weight in B is equal to 1 because both criteria contribute equally to the entire process of the product. The method is repeated for each of the remaining criteria until each criteria design alternative rating are complete. The table is used to calculate the value of criteria weight. The value of each metric must be divided with the sum of each engineering characteristic. From the result, the consistency check for this project are evaluated in this table. Consistency ratio is 0.08 which is lower than 0.1 and the level consistency is accepted. If A and B criterion is compared to the metric entry given value, the method is repeated for each of the remaining criteria until each criterion design alternative rating are complete. The second method is path chart. In this table, the benchmark that almost similar to the concept design is solar dryer dome technology. It was chosen as the datum for the first path chart since it is a competitive. Concept 2 has the lowest total weighted score, which is -1. Concept 1 and 3 have the highest overall weighted score of 4, while Concept 4 has the total weight score is 1. As a result, Concept 1 and 3 is share the total weighted score so that the second path chart is created to find the best concept. Concept 1 as a datum, the second path chart is calculated. Concept 1, 2 and 3 are similar in terms of hygienity, easy to operate and safety. In comparison to Concept 2 and 4, Concept 3 has the greatest total weighted score. As a result, the second path chart leads to conclude that Concept 3 is the best concept among the others. The third method is weighted decision metric. In this method, we identify the design criteria by which the concept will be evaluated. The design criteria have been separating which are cost, functionality, and quality in service. The design criteria are defined to our project as material cost, maintenance cost, manufacturing cost, portability, safety, easy to install, easy to operate, affordable, and high power delivery. From this table, the rating for each concept has been obtained. This table purpose is to choose the best concept design from the 4 that have been shown. The result shown that the concept 1 get the rating is 6.86, for concept 2 is 6.33, for concept 3 is 6.92, and concept 4 is 6.45. So, from the table weighted decision metric, indicate that the best overall design concept would be concept 3. This is because concept 3 achieved the highest rating. The concept 3 is selected as the final design concept that chose due to the highest value obtained from ASP, path chart, and weighted decision metric. The main component of this concept is solar panel, sensor, and Arduino. This type of design can be used automatic controller by Arduino that can be control the temperature and detect a danger. It can be reduce human energy, increase efficiency of drying process, and also increase the productivity.